Hello everyone, welcome back to my channel. In this video, I'm going to discuss the last chapter, that is chapter 15 on class 10 mathematics, that is probability. So what is probability? Probability means chances of occurrence of an event. Now, probability can be divided into two parts. One is experimental probability and the other one is theoretical probability. Experimental probability and theoretical probability. Experimental probability, also known as empirical probability. Now, the probability of events which were based on the results of actual experiments is known as experimental probability, which you have studied in class 9. Now, if we discuss an experiment of tossing a coin 1000 times, and if we note the frequency of the outcome, suppose on tossing a coin 1000 times, the number of heads coming up is 455 and the number of tails coming up is 545. Now, based on this experiment, the experimental probability of a head is 455 out of 1000, which comes to be 0.455, and that of getting the tail is 545 out of 1000, which comes out to be 0.545. Now, these probabilities are based on the results of an actual experiment of tossing a coin 1000 times. For this reason, they are called experimental or empirical probabilities. In fact, experimental probabilities are based on the results of actual experiments. Moreover, these probabilities are only estimates, because if we perform this same experiment for another 1000 times, then we may get different data giving different probability estimates. Now the next is theoretical probability, or we say classical probability. Now here we tossed a coin 1000 times, but if the coin is tossed up to say 1 million times or 10 million times and so on, then we will see that as the number of tosses increases, the experimental probability of the head or the tail, they will seem to be settling down around the number 0.5, which is equal to 1 by 2, which is what we call it the theoretical probability of a head or getting a tail. So in this chapter, we will study about an introduction to the theoretical probability or classical probability of an event, and we'll discuss some simple problems based on this concept. Now there are like a few things that we need to know. So the first one is equally likely outcomes. Now, let us consider a situation in which a coin is tossed at random. We know in advance that the coin can only land in one of the two possible ways. that is head up or tail upside. We can reasonably assume that each outcome, head or tail, is as likely to occur as the other. We refer to this by saying that the outcomes head and tail are equally likely. Now, for another example of equally likely outcomes, suppose we throw a die once. A die will always, it will always remain as a fair die, of course. Now, but what are the possible outcomes? They are number 1, number 2, 3, 4, 5, and 6. Here, each number has the same probability of showing up, so they are equally likely outcomes. Okay. Now, are all the outcomes of every experiment equally likely? Let's see. Suppose that a bag contains 4 red balls. Suppose a bag contains 4 red balls. So red balls 4 and 1 blue ball. So number of blue ball is only 1. And suppose we draw a ball without looking into the bag. What are the outcomes? Are the outcomes a red ball and a blue ball equally likely? Now, since there are 4 red balls and only 1 blue ball, we would agree that we are more likely to get a red ball than a blue ball. So, the outcomes are not equally likely. However, the outcome of drawing a ball of any color from the bag is equally likely. So, all experiments do not necessarily have equally likely outcomes. Now, the theoretical probability, also called classical probability, okay? So the second one, if E is an event, then the theoretical probability of this event E given by P of E. So probability of your event E is given by the formula number of outcomes favorable to E divided by total number of outcomes, total number of possible outcomes. Now the third point, an event having only one outcome of the experiment is called an elementary event. Now, we also know that the sum of the probabilities of all the elementary events of an experiment is equal to 1. So this is true in general. The fourth one, if E is any event, then the event E bar, or we say not E. Okay, if E is an event, then the event E bar, or we call this as not E, is called the complement of the event E. So we also say that this E and not E are complementary events. Or probability of an event E plus the probability of not an event E or not E is always equal to 1. Now the fourth one, the probability of an event which is impossible to occur is 0. Such an event is called impossible event. I hope this is number 4. No, this would be point number 5. Okay, this would be point number 5. So this number 5, not 5, says that the probability of an event which is impossible to occur is 0, or such an event is called impossible event. Number 6, the probability of an event which is sure to occur, or we say certain to occur, is 1. Such an event is called sure event or certain event. Again, let me repeat. Point number 6 says, not 6 says that the probability of an event which is sure to occur or certain to occur is 1. Such an event is called sure event or certain event. And point number 7, from the definition of probability, the numerator is always less than or equal to the denominator. Therefore, the probability of an event is always greater or equal to 0 and less than equal to 1. If it is an impossible event, it will be 0. If it is a sure or certain event, it will be equal to 1. Now, let us discuss about playing cards. Have you ever seen a deck of playing cards? Okay. A deck of playing cards consists of 52 cards. 52 cards, which are divided into 4 suits of 13 cards each. They are heart, hearts, diamonds, club, and spade. Now, this heart and diamond, they are red in color, whereas the club and the spades are black in color. So in a deck of 52 cards, okay, we have 4 suits, that is the heart, diamond, club, and spade. Heart and diamonds are red in color, whereas the club and the spades are black in color. And each of these suits have 13 cards each. Heart has 13 cards, diamond has 13 cards, club has 13 cards, and spade has 13 cards. So 13 4 times is 52. All of these cards has 1 king each. All of these cards has 1 queen each. All of these cards has 1 jack each. All of these cards has 1 number 10 each, 1 number 9 each, 1 number 8 each, 1 number 7. Each of these has 1 number 6, number 5, number 4, number 4, number 3. All of this is number 2, 1 number 2 each, and each of them has 1 ace card each. Each of them has 1 ace card. So altogether in a deck of 52 cards, there are 4 ace cards. Now this king, queen, and jack, they are called the face cards. They are called the face cards because there is a face in it. Now, so in a deck of 52 cards, altogether there are 12 face cards. Now, the red face cards will be 1, 2, 3, 4, 5, and 6. So there are 6 red face cards and there are 6 black face cards. Now, since the heart and diamond, they are red in color, so altogether there are 26 red cards and there are 26 black cards. So that's all about the playing cards. We'll see more of it when we are discussing question on the playing cards. Now let us see exercise 5.15.1. Here the first question number 1 is fill in the blanks, that is to complete the following statement. So from the explanation that I have given to you from the introduction about the probability and from the notes, there are 7 notes points that I have given to you. So you remember those points, then you can easily complete the statement that is given in question number 1. So that will be an assignment. Now let's see question number 2. The question number 2 says, the first question, here the question number 2 says, which of the following experiments have equally likely outcomes? And we need to explain. The first one, a driver attempts to start a car. The car starts or does not start. Now, in this case, it is not an equally likely event because it depends on various factors such as whether the car will start or not. And factors for both the conditions are not the same. So, this is not an equally likely outcome. Number 2. A player attempts to shoot a basketball. She shoots or misses the shot. Here in this case also, it is not an equally likely outcome, or it is not an equally likely event because it depends on the player's ability. And there is no information given about that. There is no information regarding the ability of the players. So we cannot decide it. And hence it is not an equally likely event or outcome. A trial is to answer a true-false question. The answer is right or wrong. Here in this case, it is an equally likely outcome. You can just give a brief explanation on that. Roman 4. A baby is born. It is a boy or a girl. Here it's very obvious. Okay, so if a baby is born, there are only 2 choices, that it will be either a boy or a girl. So in this case also it is an equally likely outcome. Now, let's see question number 3. Here question number 3 says, okay, let me adjust the textbook. Question number 3. Why is tossing a coin considered to be a fair way of deciding which team should get the ball at the beginning of a football game? That's the question. Why is it so? The answer is, when we toss a coin, the possible outcomes are only 2. That is head or a tail. And they are equally likely outcomes. Therefore, the result of an individual toss is completely unpredictable. And hence it is considered to be a fair way of deciding which team should get the ball at the beginning of the game. Okay, let me repeat the answer. When we toss a coin, the possible outcomes are only 2, that is head or a tail, which are equally likely outcomes. Therefore, the result of an individual toss is completely unpredictable. Hence, tossing a coin is considered to be a fair way of deciding which team should get the ball at the beginning of the game. Okay. Question number 4. Which of the following cannot be the probability of an event? There are 4 choices provided. Choice number is 2 by 3. Choice number B is minus 1.5. Choice number C is 15%. 15% is 15 by 100. And choice number D is 0.7. Now, in the note that I have given, from the 7 points, okay, I have mentioned that the probability of an event is always greater or equal to 0. Also, it is always greater or it is always less than or equal to 1. So the probability of an event is always greater than equal to 0 or always less than or equal to 1. This implies that the probability of an event cannot be negative or greater than 1. Here number B is negative, so it cannot be. Okay? So out of the alternatives given, this minus 1.5 cannot be the probability of an event. Here is Roman A is 2 by 3. 2 by 3 means 0.66666666, which is less than 1. Here option number C is 15%. 15% means 15 by 100. That's 0.15. Here option number D is 0.7, which is also less than 1. So the option number B is incorrect. So option number B is the option which cannot be the probability of an event because it is negative. Now the fifth question. If probability of an event E is 0.05, then what is the probability of not E? We have discussed in the note from the 7 points that the probability of an event, the sum of the probability of an event and the probability of not an event is always equal to 1. Here E and not E are called complementary events. So here in question number 5, the solution says, here probability of an event E is given to be 0.05. We are asked to find out probability of not E, or we write E complement. Now we know that the sum of the probability of an event and not an event is 1. So probability of an event plus probability of not an event is always 1. Therefore, the probability of not an event will be 1 minus probability of your event E. So that's 1 minus 0.05. Okay? Which is equal to 0.95. Now the next question, question number 6. A bag contains lemon flavored candies only. Malini takes out one candy without looking into the bag. What is the probability that she takes out? Number 1, an orange flavored candy, and number 2, a lemon flavored candy only. Now we need to know that a bag only contains lemon flavored candies only. So there is no chance of getting an orange flavored candy. So how do we answer this? Okay. Now the bag contains lemon flavored candies only. It does not contain any orange flavored candies. This means that every time she will take out only lemon flavored candies. Therefore, even that Malini will take out an orange flavored candy is an impossible event. So the probability of getting an orange flavored candy will be 0. Roman 2, what about a lemon flavored candy? Okay, as I'm saying, as the bag contains only lemon flavored candies, Malini will take out only that. Therefore, the event that Malini will take out a lemon flavored candy is a sure event. Hence, the required probability of getting a lemon flavored candy will be 1 because it is a sure event or certain event. If it is a sure event, then the probability is 1. If it is an impossible event, the probability is 0. Since Roman 1, okay, the probability of getting an orange flavored candy is impossible because there are no orange flavored candies in the bag. Hence the probability is 0 because it's an impossible event. Whereas number for Roman 2, since the bag contains only lemon flavored candy, so every time as Malini draws a candy from the bag, it is always be a lemon flavored one. So it's a sure event or a certain event. So in that case, the probability is 1. Now the next question, question number 7. It is given that in a group of 3 students, the probability of 2 students not having the same birthday is 0.992. what is the probability that two students have the same birthday? Here, two students not having the same birthday and two students having the same birthday are complementary events. They are opposite to each other, so they are complementary events. So in that case, the sum of the probabilities will be 1. The probability of not having the same birthday and the probability of having the same birthday. So the sum of the probabilities will be 1. So what I'm going to do is I'm going to write a solution. So question number 7. Now we want to find out the probability of two students having the same birthday, and the probability of two students not having the same birthday is given. So let E be the event of two students having the same birthday. Then if is the event of two students having the same birthday, then E bar or not E will be the event of two students not having the same birthday. Now we know that probability of an event plus probability of its opposite event or not an event is 1. Now the probability of two students not having the same birthday is given. It's given that P of not E is given to be 0.992. So your probability of event E means having the same birthday will be 1 minus P of E complement. It is 1 minus 0.992. You subtract it, then it gives you the required result, which we got it as 0.008. So the chances of not having the same birthday is more as compared to the chance of having the same birthday. Next question. Number 8. A bag contains 3 red balls and 5 black balls. One ball is drawn at random from the bag. What is the probability that the ball drawn is number 1 red, number 2 not red? Not red means it's opposite of red. So red and not red are complementary events. So the sum of their probabilities is 1. So here let us write down the solution. Question number 8. Number of red balls. Number of red balls is given to be 3. And number of black balls is given to be 5. So the total number of balls will be equal to 3 plus 5, 8. So altogether there are 8 balls in the bag. Now, the first one is Roman 1. We have to find out the probability of drawing a red ball. So let me represent drawing a red ball by an event E. So let E be the event of drawing a red ball. Therefore, probability of your event E. Now we have seen that the probability formula is number of favorable outcomes by total outcomes. Here there are 3 red balls, so you have only 3 chances. So number of favorable outcomes is 3 by total number of outcomes. Altogether there are 8 balls, so 3 by 8. Now Roman 2, we want to find out the probability of not red. So let me write, let E bar be the event of not drawing a red ball. Then in that case, probability of an event E plus probability of not E is always 1. So probability of not E will be 1 minus probability of E, which is 3 by 8. So if we take LCM, we get 5 by 8. Now question number 9. A box contains 5 red marbles, 8 white marbles, 4 green marbles. One marble is taken out from the box at random. What is the probability that the marble taken out will be red? Number 2, white. Number 2, not green. Not green means it will be either red or white. So let us solve this. Number of red balls or number of red marbles is equal to 5. Number of white marbles is 8. Number of green marbles is 4. So the total number of marbles will be 8 plus 4, 12, 12 plus 5, 17. Now we want to find out the probability of that the marble taken out is number 1, red. So we can denote this event by E1, second one by E2, third one by E3, and so on. So let E1 be the event of getting red marble. Now there are 5 red marbles, so the number of favorable outcomes is 5. So probability of red marble E1 will be number of favorable outcomes, which is 5, by total outcomes altogether 17 marbles, so 5 by 17. Very simple. Roman 2. This time you want white marble. So let us represent E2. So let E2 be the event of getting white marble. So your probability of E2 will be, there are only 8 white marbles, so the number of favorable outcomes is 8 by total number of outcomes 17. Roman 3. Not red. Not red means we include the white marbles and the green marbles. So the number of marbles which is not red is 12. So we can denote by E3. So let E3 be the event of not getting red marble. So probability of E3. So altogether there are 12 marbles which is not red. So your number of favorable outcomes is 12 by total number of outcomes 17. Question number 10. Let us see the question together. A piggy bank contains 150 pice coins. So the number of 50 pice coins is 100. 50 rupees 1 coins. So the number of rupees 1 coins is 50. 20 rupees 2 coins. The number of rupees 2 coins is 20. And 10 rupees 5 coins. So the number of rupees 5 coins is 10. If it is equally likely that one of the coins will fall out when the bank is turned upside down, what is the probability that the coin will be? Number 1, 50 pice coin. And number 2, will not be a rupees 5 coin. So let us find the solution. Now, number of 50 pice coins is 100. So 50 pice coins is equal to 100. There are 100 numbers. Rupees 1 coins. There are 50 numbers. Rupees 2 coins. There are 20 numbers. And rupees 5 coins, there are 10 numbers. So altogether 150, 60, 70, 80. So the total number of coins will be 180. Now, here we have to find out what is the probability that in first one, the coin will be 50 pice coin. We can always denote by E1, E2, E3, or we need not necessarily do that. This time I'll be doing direct. We want to find out the probability of getting 50 pice coin. Now, we know that the probability formula is number of favorable outcomes divided by total number of outcomes. There are only 100 number of rupees or of 50 pice coins. So number of favorable outcomes is 100, but altogether 180 total number. 2 5 times, 2 9 times. So your probability is 5 by 9. For 1 2, you want to find out the probability of not getting rupees 5 coin. So you don't want rupees 5 coin, means you want 50 pice, you want rupees 1 coin, you want rupees 2 coins. So altogether there are 170 coins, which is not rupees 5. So your number of favorable outcomes will be 170 by total 180. So that's 17 by 18. Okay, in this video we'll just simply work up to only question number 10. So I'll be uploading the remaining questions in the next video. So see you and study hard.